Yeah, hi everyone, it's Mr. Michael here again. Today I want to show you a few examples of how to calculate the length of a line segment using the distance formula for a line segment. So you can kind of see it is a variation of Pythagoras' theorem. What is a line segment? Okay, a line segment is basically a line that goes from any 2 points on the Cartesian plane. So if here's a Cartesian plane, with my x and y axes, a line segment simply is a line that starts at a point and ends at a point. Okay, and what is the distance of that line? The reason we're using a variation of Pythagoras' theorem is because we can kind of make a right-angled triangle out of this line segment. And you can see that the distance there is going to be equal to the square root of the square of the two shorter sides. Okay, so I'm going to go through a few examples. The examples I'm using are straight from the textbook here. So I'll be going through example 21A and 21B on page 43 of your textbook. To do that, I'm going to just start on fresh piece of paper. I've already drawn a Cartesian plane and a line segment from this point 0,2, coordinate 0,2 to this point 1,7, and I'm going to show you how to actually calculate that distance using that formula we saw on the previous page. So again, that formula is distance is equal to square root of x2 value minus the x1 value, all squared, plus y2 value minus the y1 value, again, all squared. Looking at this line segment, I've got 2 points, 0,2 and 1,7. We know that the first number in each coordinate is the x value. So I'm going to go ahead and label this x1. I'm going to label this x2. I'm going to label the second value in each set of coordinates as y2. So let's try to refocus that. y2, oh sorry, y1 here, and y2. Okay? So from there, I'm literally just going to substitute those values into this formula. Okay? So let's go ahead and do that. Distance is going to be equal to, again, square root of, let's just keep it short, x2, which is 1, minus x1, which is 0, all squared, plus y2, which is 7, minus y1, which is 2, again, all squared. Okay, now I'm going to go ahead and work out what those values are inside the brackets. So d is again equal to the square root of 1 take 0 is 1 squared, and 7 take 2 is 5, and again squared. Now 1 squared and 5 squared respectively are 1 times 1 is 1, 5 times 5 is 25. That gives me the distance of the square root 26. Now it's probably best at this point to leave it in exact form, given that, you know, square root 26 isn't going to give us a whole number. Okay, so that's an example there. I'm going to show you another example. Again, I'll use the textbook example of page 43, and this time there's some negative values there you can see. Okay, so when I do this one, I'm not going to actually, I'm going to write those down while that page is still open, so it's, you can't see this at the moment. Minus 3, 8, and 4, minus 1 of the coordinates. There's no need to actually go ahead and draw that line segment, okay, because essentially all we're doing is we're substituting those values into an equation. So again, I'm going to start with that equation. D equals, okay, x2 minus x1 all squared plus y2 minus y1 all squared. The next thing to do is actually label those values inside those 2 points or those 2 coordinates as x1 and x2. Remembering that the first value inside each bracket is the x value, and y1 and y2. Notice how this coordinate has both x1 and y1, and this coordinate has both x2 and y2. That's really important that we're not labeling this x1 and y2. These are both the 1 values, and these are both the 2 values. Okay, that's really important, and it's a common error across the board. So once we've done that, we just then substitute those values into this equation. Let's do that again. Again, that equals x2 is 4 minus, this time x1 is minus 3. So it's 4 take minus 3 squared plus y2 take y1. y2 in this instance is minus 1 take y1, which is 8. Again, all squared. Okay, this is a little bit more complicated. It involves some negative numbers, but we've got the skills to work this out. So, what is 4 take minus 1? When we see those two minus signs next to each other, that actually becomes a, yeah, you guessed it, positive. So it becomes 4 plus 3, which is 7 squared. Add. Now, the two signs aren't next to each other here, so it's still minus 1 take away 8, which is actually negative 9. Okay, again, all squared. So now I'm going to go ahead and actually square these values. 7 squared, 49. Minus 9 squared, remember that's minus 9 times minus 9. Okay, and that is minus times a minus a positive. So that becomes 81. Alright, now again I'm going to go ahead and add these two values together, which gives me square root of 130. And again, 130 is not a square number. I'm going to keep it in exact form. The distance between these 2 points, minus 3, 8, and 4 minus 1, is the square root of 130. Okay? Hopefully that helps, guys. Look, you can go back, pause the video at any time, take some notes, use this as a blueprint for when you're answering the questions in the textbook. Again, thanks for watching.